Alright, so you already practiced a little bit with the blue man, but we're going to go a little bit more in depth here and talk about different dominant and recessive ones. So the blue man was a recessive pedigree, you should have found, and now we're going to look at dominant and recessive here. So you're going to be able to read pedigrees, determine the trait is dominant, recessive, and complete Punnett squares from the pedigree. So again, why are you doing this? Well, let's see. Tay-Sachs. You can actually go and Google a movie on Tay-Sachs. Don't do it right now, but you can do it at home. And it's a very devastating disease. The kid usually dies by 3, or by the age of 5, 3 to 5. That's because their brain actually just like deteriorates and they regress, and eventually they're still eating out of a bottle at like 3. All right, it's a very depressing disease, and you don't want to have that carried on. So you want to know if you're going to be a carrier or not. So we're going to be learning how to read these pedigrees to see if you're a carrier. Alright, so there's the induction and relevance. Alright, so this is autosomal dominant. So I already told you that this one's autosomal dominant. And down here we have 4 little things that give you an idea if it's dominant or recessive. Alright, if it's dominant, if 2 affected people have an unaffected child, it must be a dominant pedigree. Because remember, if these 2 were little r, if the trait was recessive, then all of them would have had the little r's. That's the only thing they can donate. But remember, this trait has to be dominant here because they can be big R, little r. So they still have the trait, so they're fully colored in, and then this person can get little r, little r. Alright, so that's why that one has to be dominant. You also see that these 2 parents here, since they're little r, they only have kids without the trait, little r, little r. Alright, that would be a dominant pedigree. Also, dominant pedigrees, generally you see more people with the trait than not. Alright, most of the time we're going to be dealing with this one. This one's over here is recessive. The big key giveaway with recessive is that generally with recessive pedigrees, there are carriers. Carriers are your big little. That means they don't have the trait, but they carry the recessive allele. Alright, that's the easiest way you can tell it's recessive. So this is a recessive pedigree. Alright, so that's the easiest way. The other way you can tell is that it skips generations. If you look here, generation 2, these parents, neither of them had, well actually these parents didn't even have the trait either because they're only halfway colored in. So these 2 parents didn't have the trait, yet one of their kids from this grandparent had the trait, and one of these parents had a kid with the trait. Alright, and actually there's something wrong with this pedigree because if this kid has the trait here, little r, that means both of these had to be carriers, big R, little r, and these should have been halfway colored in. Alright, and these are big R, little r, so that's why they could get 2 little r's there. Alright, so again, if it's a carrier, you can also get 2 adults that don't have the disease and pass it on to their kid with the disease of recessive. And most of the time, when in doubt, just guess it. It's going to be recessive because more often than not, it's not. So what you're going to be doing is not only going to be doing that, but then let's say I ask you that these 2, well, they're brother and sister. Let's say this guy right here, and we know he's little r because he doesn't have the trait, marries someone who is a heterozygote. Alright, and then you just do your Punnett square to find out what percent of the kids would have the disease, and that would be 50%. Alright, 50-50. Alright, so then you're just going to have to do your Punnett square. So once you identify who has the trait, and if it's dominant or recessive, it's pretty easy from there if you know how to do the Punnett squares. Alright, so that's it for this one.